Hi everybody, today I'm going to attempt to do a video on how to set up HEC-HMS which you're using for your stormwater modelling project. I'm going to base it on, I'm going to set it up using the example in your project and I'll get as far as I can. And then the rest is up to you. You need to use HEC-HMS on your computer. If you have any issues installing it on your computer or anything like that, just please email me, let me know. Otherwise, you need to run your own model and provide me the information for the assessment. So to start with, let us just have a look at the So if you open up the TP108 document, you can see that actually this example that we're working through for your project has been set up by them in here as well. So they've actually got the outputs of what you should get from your TP108 assessment all listed there. And you can use these. So what you do is get all that information from the TP108 assessment, and then that gets input into the HEC-HMS model. So basically for this kind of project, you should get pretty similar results from doing it with TP108 as you do from doing it in HEC-HMS. So that is the goal of this exercise, to sort of make sure that your model is set up correctly so that you do get that. So you can see the same as before, the same kind of inputs: area, the curve number, 71.5, the initial loss, which is what comes out of the TP108 spreadsheet, and the lag that comes out of the TP108 spreadsheet, etc., etc. So let's have a go at doing it. I will stop sharing that screen and I will share the other screen. Here you go. This is HEC-HMS. You can see it's a bit ugly, but anyway. So the first thing that we need to do is we set up a bunch of, set up a new project. New, let's call it Pakuranga. And we create that to make sure it's set to metric. So this is Pakuranga. Now we go to components. This is create components. This is where you add all of the things. So the first thing we're going to do is create a basin model, basin 1, and change it if you like. And you go like that, and that's where you can see it. So we've got a basin model, and then we are going to create a sub-basin. So basically this is our sub-catchment, and the first one is going to be called Pakuranga pervious. I'm just going to put perv there, and then we've got to do another one over here, which is called Pakuranga imperv. Yeah, so we created our 2 different catchments. The other thing that we're going to have to add is where they're draining to, or a point that we're observing, which we can use a bunch of different things, but let's just, for argument's sake, use a junction. And obviously we've got to connect these. So this here, junction 1, is the point we're looking at. So that's where we're combining all of the flows from the impervious and the pervious areas and seeing what our total flows are. We connect them with what's called a reach. So you just go up to the little icons, reach creation, and you go just draw a line. That's reach 1. Draw another line. That's reach 2. Done, burgers. So now that's, and you don't have to be accurate at all with, similar to Ethernet with where it is in space, because we input all of that data. So then we go across to here, and we can start inputting the information. So this is for the pervious one. So pervious catchment. And it's important to tell the model what is downstream of that catchment. So pervious downstream is reach 1, sorry, because that way we connect these 2 things together. We know the area of our pervious catchment is 1 in kilometers squared is 1.86 kilometers. Don't worry about any of this stuff. Just leave that all stays the same. The only thing we need to change in here is our base flow method, and we basically want to say oh no, sorry, we'll leave it as none. We want no base flow. So we're using the SCS curve number method, unit hydrograph. That's all what we're using. So that's cool, doesn't need to stay. We go across to loss, and this is where we put our initial abstraction number. So if you see on, we've got 1.5 millimeters if you see in your results from TP108, and our curve number is 71.5. You see it from your results, and our percent impervious is left at 0. So that's it. We look at transform. Just leave that lag time, SCS lag. So that's the lag time that's given as from TP108 of 0.48. Options, that's pretty much all we need to put in. So then we've put in the information. Oh, why was that correct? Pervious. Oh, okay, I think I've connected them. Let's change it to reach 2. Yeah, cool. Then we're connected to the right one over there. Yeah, so then you have to go through and put the same information in for the impervious catchment. So it is, again, impervious, the area, which for impervious is 1.36 kilometers squared. We don't need to add anything into there. Loss, initial abstraction is 0. The curve number is 98. Percent imperviousness, we are leaving at 0. Transform, we've got our lag time here, which we worked out was 0.36 hours. Oh, we better convert that into a minutes. So if we go, so that's 21.6 minutes. Yeah, and when they follow that the same, let's just go back and make sure that we put the right information in here. For our transform, that should be in minutes, not hours. So it's 0.48 times 60, should be 28.6. Okay, so that is setting up our subcatchments. So back to, we go back to Pakuranga impervious. Make sure that we've connected. So what is downstream is junction 1. No, not junction 1, sorry, reach 1. Yeah, and then we just have to connect everything else up. So where is reach 2? What is downstream from reach 2 is junction 1. We don't need to worry about any of those. This is where you can change the different methods used to route that hydrograph, but we don't need to worry about that. That is all being put into the other thing. Reach 1. Again, what is downstream of reach 1 is junction 1. Yeah, routing, all good. So that is now all connected up. So we've got all of our basin information. Just going to pause this. I'm going to stop this video now and do it in little chunks so that you don't get overwhelmed. There we go.